All right. Hello, my name is John Hildebrand. I am a technical marketing engineer at Cohesity, and what I'm going to present here about is we're going to talk about using the Cohesity platform for what we dub application mobility for test dev across multiple data centers or public cloud. So a little bit about Cohesity to begin with. Founded in 2013 by our CEO, Mohit. He's a co-founder of Nutanix at the same time, so if there's a lot of similarities between some of what Nutanix does and what Cohesity does, that's one of the reasons for it. Also, he was one of the leads on the Google file system, so there's a lot of Google influence across our platform. So at the same time, we've got multiple different persons working at the company from various other big-time companies like Google, VMware, EMC, NetApp as well. At the same time, recently we've announced some big top-tier investments, including adding SoftBank and continuing partnerships with HPE and Cisco at the same time. So what are we here to talk about? Well, our base software platform, the Cohesity Data Protect, our data platform. So what we have here is we're known mostly for what we call secondary hyperconverged storage, but we have so much more when it comes to our cloud offerings at the same time. So if you base the fact that that's the on-premises way to ingest data, we have multiple ways to also extend cloud connectivity, cloud archiving, the ability, or what we're going to get into, which is our product called CloudSpin in a little bit. But we do a lot of things with we have some long-term retention, VM migration, some test dev capabilities, some cloud native backups. So once we run our particular data platform in various public clouds, we also work with their APIs for more cloud native backups. Full lifecycle disaster recovery, failover and failback. And at the same time, multi-cloud mobility. We have some capabilities of being able to take, say you start off on AWS, but now you want to be on Azure. We have ways to be able to migrate things over from one cloud platform to another without really skipping a beat in the data platform itself. So one of the first things that we generally go over with on our cloud portfolio is what I like to dub our low-hanging fruit to some degree, is our product Cloud Archive. Idea here is we can add some sort of external connectivity to do our long-term retention. Basically in the cloud, but we can also work with things like NFS shares or S3 compatible, just in different locations. At the same time, we get our standard encryption and our dedupe and compression capabilities on top of it. And at the same time, plugged into it, we can also then drill into file level restores, not just necessarily VM constructs as well. And we also have cloud retrieve. So once we put our cloud archive data, as long as we have another data platform system available, whether it's in the cloud, at another physical site, another hyper-converged appliance, we have the ability to then take from that archive and move that data down to another location. So one of the things that I'm mostly going to focus here on this is the concept of VM migration. So we have the capability through our policy engine on an on-premises version of the data platform to take a backup of that particular virtual machine. So think of it in normal VM speak. We're going to do a snapshot-based backup, and we're going to ingest the data into the platform. Then what we're going to do is we're going to perform our CloudSpin operation. So what we're going to do is the VMDK in question that's created from the VMware environment, we're then going to go through a conversion process. So depending upon if it's Azure or AWS, there's two different methods to go for as far as the migration concerned. So what we're going to do is we have built into it, the CloudSpin application will do the conversion for you for one of those platforms. And at the same time, if need be, we can also launch an instance of that virtual machine in the cloud. Now, the thing here with that, the launching, is we already have to have some of our cloud components pre-created. So your networking already has to be there. You have to already have storage accounts in the case of like Azure. So you already have to have some sort of a cloud, kind of almost parts of it already pre-created to be able to use it. Now what it allows us to do is we can easily migrate the data to public cloud, and at the same time, the conversion process is taken care of. So one of the things about this particular presentation we wanted to at least get out and about is the fact that we don't have to change or don't have to do anything funny with the data housed inside of that VMDK to actually migrate it to these public clouds. We're going to take care of an easy conversion process, and what you had in your environment should run in the public cloud. So As far as the CloudSpin platform, there's two different methods. I mentioned we had policy, which allows us on the bottom. I misdid the order here, but we have what's called a protection job in our system. And what that does is when we perform the VM level backup within the vSphere environment, then once that's finished, we will then create a copy of that particular VMDK over into our cloud accounts. We also have what's called our test dev UI, which basically just means I'm going to connect up directly to that environment. I don't need a protection job, but I'm going to tell it, go grab the VM from the live environment and do the conversion without having to worry about the protection job. So the only thing, again, is you do have to have your networking information. You're going to end up with a virtual machine instance, whether that's an EC2 or an Azure, and you do have to know what region and what virtual machine type you're going to want to run that as when you push it out there. So the workflow is, it does differ depending upon the clouds. So as far as AWS is concerned, AWS does have a migration API already built in. So when I think of what AWS has to do, when you do the initial copy of the VMDK file, it's got to go to an S3 bucket to begin with. Then from there, behind the scenes, there's going to be a creation of an elastic block storage snapshot and a creation of an AMI, so an actual image then that you can work with and deploy multiple instances of the virtual machine. At the same time, if you're going to go and actually turn on an instance, it's going to turn on the we're going to enable an EBS volume for that EC2 instance, and then actually fire the virtual machine up. So it's going to do everything after connecting to the networking, grab an IP address, things like that. Azure's conversion is much simpler due to the fact that there's a lot of similarities between what VMware does with VMDKs and what Microsoft does with the VHD or the Hyper-V format. Essentially what happens is header information gets wiped out from the VMware side, and the Microsoft version, we basically write a new header to point to the same data. So as you can probably tell based off of that, less steps means Azure doesn't take as long as AWS's process is concerned. So the app mobility for failover capability. So now that we've started to work with the CloudSpin component, what we can do is, on premises, we can essentially take entire application sets. So in this case, we're getting an example of web app VMs and SQL VMs. We're ingesting those into the data platform. We're going to convert those particular VMs with CloudSpin over to our cloud in question. And based off the fact, if we have a cloud edition running out in AWS or Azure, also listed, GCP is listed here, but we don't have a conversion yet for Google Cloud Platform. But I would assume since we have Cloud Edition running, we will have CloudSpin available at some point for it. So once we get that out there, now we've got the data and our VMs running out in the public cloud. And at the same time, now we're backing them up with the Cloud Edition side of the equation, which allows us, with the failover, we go one direction to public cloud. Now let's do this coming back. Okay, well, flew by that one. Previous. Okay, so now from the data platform from the Cloud Edition, we can then CloudSpin the VM back to an on-premises version of it. So we can, if we build data into our cloud instances, we can essentially harness them and pull them back into on-premises at the same time, and essentially allow for the idea of failover, failback from public cloud to private on-premises. At the same time, one of the interesting things that we can do, and we've had some people challenge us on, if you have a Cloud Edition running in AWS and in Azure, you can CloudSpin between both of those at the same time. You can go AWS to Azure, Azure to AWS. Okay, so a little bit here as far as CloudSpin demo from a UI perspective. Unfortunately, that's not going to work. Well, from our UI perspective, here we go. So I'm going to try to skip through some of the video here. So from a UI perspective, we're going to show via a policy. So we're going to essentially create a policy. We're going to call this CloudSpin to AWS, and we've got an option down here for CloudSpin. We've already created a connection to AWS within the platform. As you can see, I can select my region of choice, so I'm going to do US West 1. and create my policy. Now what I have to do is I have to create a protection job. We're going to go into the protection job UI. Now also I will also mention at the same time, this is all available to do also with REST APIs as well. So normally I would love to show this via, say, PowerShell scripting or something with a JSON file somewhere, but it looks a little bit better than having to go through a couple lines of code to make it happen. So what we're doing here is we're kind of what I mentioned about the Google influence. We have Google-like searching through some of our indexing. I found the VM in question based off of just putting in CentOS, looking through my vSphere environment. So now I applied my policy. I'm going to connect to what's called our storage domain, which is the storage in the platform itself that we're going to actually bring the snapshot into. And then what we're going to do is we're going to fire the job off. And what's happening here is that the job is initiated. We're in the midst of performing things in the vSphere environment. I'm going to cut ahead a little bit. And now we're in the CloudSpin portion of this. And what I'm taking a look here, we're actually doing the S3 initial VMDK copy, because there appears to be a file that has something named VMDK and the VM in question. So after we've finished, I'm going to go back and check EC2 one more time. Notice it took about 16 minutes. A lot of it depends upon speeds and feeds. But after a refresh, now I have things like an EBS snapshot based off of running AWS VM import. So now I have an EBS snapshot to work with. And what I should also have available here is an AMI, so a full-fledged image that I can reference and then en masse deploy with that AMI code. So that is how we go through from a policy perspective. I'm going to skip ahead and now show from a test dev UI perspective. We're not going to associate this with a backup job and have that run in front of it, but what we're going to do is we're going to harness an existing backup job that may have already happened with the system. So the data is already on the storage system in question. So I found the job, and now I have to answer some questions related to the cloud account that I'm going to connect to. I can do things like add prefixes or suffixes to the name automatically, so I can label it appropriately. But now I'm going to look through my source, and I'm going to find my AWS account. And just like I mentioned prior to this, now I got to figure out what region. Now I got to do an instance type. So we got a bunch of the different instance types that are available. In this case, I'm doing a T2.small. I got to select my VPC for that account. Same thing with the subnet, and also the network security group. I also have it checked here that I'm going to actually, the VM that's created is going to power off. But it does have to do some consistency checks, and it will power it on initially, just to double check and make sure that everything's okay. All right, so now the process is running, and it, very similar to the policy part of it, we're going to go and we're going to check S3 one more time, and we're going to have a new VMDK that's been copied out there. So we have a new VMDK, and now we should, and we got to the end of it. This one took roughly about 19 minutes front to back with so again, AWS takes a little bit more time than Azure does, as we'll find out shortly. And you see we now have an actual instance. So we see that T2.small instance, it was stopped. And because I ran this video shortly after I had already created the other AMI, it's now registered in there as well. I now have an EBS store volume that backs that EC2 instance, and I should have a snapshot as well. Okay, so now that we've actually gone through and shown that we can essentially create a virtual machine disk out there, what I wanted to do is I wanted to show off a little bit, while it's not inherently in the Cohesity system, but kind of to complete the workflow idea that now I have a disk image out there. Now what can I do with these sorts of things? So I've been experimenting with HashiCorp's Terraform product a little bit. And what I'm going to do is I'm going to fire off. So I've already done a plan. So if you've ever run Terraform before, what you have to do is you have to take the code and load a plan to kind of pre-tell it what you're going to build. And now what I'm going to do is I'm going to apply that plan. Now, during the course of this particular demonstration, this will likely not finish, but what I will show you is instead, so now you have a virtual machine disk image, but what I'm going to do is I'm going to create an entire app stack based off of this. Now granted, I will state this, I had a heck of a time trying to find a web app in question to kind of show this off, but I did do a pretty good completion of showing that I'm going to create 20-some objects in Terraform using that one VM disk file that I had imported out there. So right now, we're in the midst of creating essentially our networking available out here, and I'll switch over while that's running. So this was the resource group in Microsoft Azure. If I hit refresh, you can see now I've already started to build a bunch of things. Now I've got some network security groups, an availability set, some public IPs available, and this is all coming from that Terraform file. So I'm essentially building the entire structure, and at some point, we should be getting to the point where now we're actually going to build VMs. There we go. So now I have 3 VMs that's going to constitute my web server farm. I have their network interface, the 3 virtual machines, and I have a load balancer that I'm fronting in front of this. So essentially, all I had to do was kind of perform gold master type of image creation on premises, dump that out to the cloud, and now I'm able to essentially create an entire cloud stack based off of that one VM that I pushed out there. Now, it takes about 10 minutes-ish. I'm not going to sit up here and try to tap dance too much as far as things are concerned. But what I wanted to also add onto this is, you can, in CloudSpin, do multiple VMs in one job, get all those disks out there, and then based off of it, add even more, if you want to say, more things to essentially create in this cloud stack. I wanted to show more of like adding a database engine and having that app inside of those VMs be able to talk to it. But at 2:30 in the morning, it just wasn't working out for me. So at a minimum, I can at least show that we are in the midst of creating these things. So if you notice, we're still creating the virtual machines based out of here. And like I said, the last time I did a timing on this, it takes roughly about 10-ish minutes. Azure's not exactly known for fleet of foot for getting a VM powered up as quickly as, say, AWS is. So while that's going, I guess I'll switch back to this. So based off of it, I will state that while we have the capability of being very integral into making sure that data gets ported, but from a larger perspective, when you think about the entire workflow of taking that data that you imported and getting it actually usable, what I'd love to see is us to be able to do things like plug Terraform modules into it, and I really hope that we get to a point where I can show things like that in the future. But for the moment, utilizing a bunch of third-party tools, you can take basically based off a simple backup within our platform and essentially build entire cloud stacks just with a couple of steps in between. So with that, I basically have a thank you here, and looks like I'm ending a little bit early on this one. I didn't expect the Terraform thing to last as long. So if you want, we're at booth 1420. Swing by before the end of today, and I can show off CloudSpin even more in the booth as well. So thank you.